right, lesson 6-7. You're supposed to have a dot grid for this, but I know a lot of us don't have that, or graph paper. Graph paper would work really well, but I can show you how to do this with line paper to make it work for you. So it says to draw all possible rectangles with a perimeter of 12 centimeters and sides whose lengths are whole centimeters. So basically, and then they give you 3 options here. As you can see, I already did this one, but so you need to kind of figure out what numbers would add up to 12. But it has to be a rectangle. So it'd be 4 numbers that add up to 12, but you're only writing 2 numbers there. So let me just show you what we mean. So the first one that I'm gonna do is something that's 3 by 3. And the reason I picked 3 by 3, so I'm gonna actually use my lines and go down 1, 2, 3, and then I'm gonna estimate to make it about the same. 1, 2, 3. Okay, and the reason I picked 3 by 3 is because if you have 3 here, right? Let's use those lines that are already there, and 3 here, and then you have 3 here and 3 here. You add up 3 plus 3 plus 3 plus 3, and it equals 12. Okay. And then, so they wanted, okay, and I'll just do the next one. So then the next one that I got was a different one that was going to be longer. It was going to be 4 by 2. So 1, 2, 3, 4, and then about 2 wide. 1, 2. So it's going to look more like this. Okay. 4 by 2. And the reason I picked 4 by 2 was because 4 plus 4 is 8, and 2 plus 2 would be 10, plus another 2 would be 12. And the last one I got was 1 by 5. So I'm going to draw that here. So 1, 2, 3, 4, 5, and then it only goes over about 1 space. This. Okay, and that would be 5 and 5 make 10, plus 1 is 11, and another 1 makes 12. Okay, and so what we notice, okay, so now we're supposed to find the area, and so when you find the area of the 2 adjacent sides, you're going to multiply this and this, or basically count the squares inside. So for the first one, the 3 by 3 would be 9 square centimeters. The second one, 4 by 2, that would be 8 square centimeters. And then the last one, 1 by 5, is 5 square centimeters. So then the question is, compare the shapes with the rectangles with the least and greatest areas. So the one with the least greatest area was long and skinny, and the one with the greatest area was actually a square, right? So we're going to write that. So the rectangle with the least area, is that even a word? Is that how you say it? Smallest area? Was long and thin, while the rectangle with the greatest area was a square. Okay, you guys remember this. We really did do this already, so hopefully you remember all this. Okay, so we'll do the same thing again. It says this time though we're going to make all possible rectangles with a perimeter of 22 centimeters. So we need to think of numbers that could add up to 22. So I'm thinking 20 plus 2, right? So if I was to do that, I would take half of 20, which would be 10, and then half of 2, which would be 1. So I could make one of those long, skinny ones. So it'd be down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then over 1. Okay, because that would be 1 and 1, which make 2, and 10 and 10, which make 20. So that would be 22. Okay, so let's think. Is there something else we could do? Maybe I should try something with 4, huh? What would happen then? What could I add to 4 to make 22? Maybe 18 and 4, is that right? So if it's 4, then each side would be 2, right, to make 4, and then 18 would be 9. So I could go down 9 this time. So basically all the way down except one more. And then instead of 1 over, it would be 1, 2 over. So see, it's a little bit wider now. Okay, so now it's 2 here and 2 here, which make 4. And then 9 here and 9 here, which make 18. And then if you add 18 and 4 together, you get 22. All right, let's keep going kind of in this order. Let's see, another number. What about 3? What if I did 3 across? That would be 6. And then what would I add to 6 to get 24? Would it be 18? And then half of 8. Oh, I already said that one. That's 4 and 18. Because it's 22. Yeah, we're not making 24. All right, so let's see. If I did 3 across, then that would be 6, right? And then 6, in order to make 22, let's see. So 22 minus 6 would be 16, right? So would that be 8 then? Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's actually just one shorter, right? And so then this would be 1, 2. So 1, 2, 3. So we're getting a little bit wider. Like this. So that's 3 and that's 3 and that's 8 and that's 8. So that's 16 plus 6 and that equals 22. I bet I could keep going with this pattern I've been doing. So far I've done 1, 2, 3. What would happen if I did 4? I might need to move this up so you can see. Okay, so if I did 4, then 4 plus 4 is 8, right? And then how do I get 22 if I have 8? So let's see, 22 minus 8, would that be 14? Yeah, I think so. So that would be 7. I got to make 7. I hope I have 7 lines. Let's see, 1, 2, 3, 4, 5, 6, 7. Perfect, I do. And then this has to be 4. 1, 2, 3, 4. Ooh, it's getting more square-like, isn't it? Yeah, it's starting to get shorter and wider. That's what I'm noticing. All right, so that's 7. Okay. Now, let's see. 1, 2, 3, 4, 5. So it looks like we might have to do one more of these. So let's see. Why don't we take 5 and do the same pattern that we've been doing. So 5 and 5 make 10. And in order to make 22, you have to have 6. So I guess it would be 5 by 6. So this time it's going to be a little bit shorter. 1, 2, 3, 4, 5, 6. And it's got to be 5 wide. So 1, 2, 3, 4, 5. Okay, it's definitely looking a lot closer to a square. Well, it actually is really close to a square because if it's 5 by 6, it's only one number away from the other number, right? So 5 by 5 would be a square, or 6 by 6 would be a square, huh? Oops, 5. Okay. All right, so there we go. Well, now we have to write our coordinates on here. Okay, I just realized you didn't see that. There you go. So the first one would be 1 by 10. Second one we did was 2 by 9. Third one we did was 3 by 8. Then we did 4 by 7. Then we did 5 by 6. Hey, we did a pattern, didn't we? We went up by 1 this way. We went down by 1 that way. Well, now you have to multiply those two numbers to find the area. So the first one would be 10, square cm. The next one would be 18 square cm. And then you have 24, because I'm multiplying. That's how I'm getting these numbers. I'm multiplying the adjacent sides that I wrote here. And then we got 28. And then here we got 30. Okay, so the question is, oops, it looks like a G. Okay. Anyway, the question is, compare the shapes of the rectangles with the least and greatest area. So it's basically the same thing as last time, right? The long, skinny one that we did here had a smaller area, and the one that was close to a square had the biggest area, okay? So I'm going to go ahead and write that. So the shape with the greatest area was closest to a square. So the shape with the greatest area was closest to a square. Well, I guess I'm writing this opposite. While the long, thin rectangle had the smallest area. All right, let's move on. All right. Okay, so they want us to do the same thing here.